Hi everyone. Today we're going to start Unit 3 and we're start by talking about inequalities. Our goals for today are to write an inequality from a verbal phrase, write an inequality from a real life situation, and to graph an inequality. That sounds like quite a bit of things we want to accomplish in one day. So let's take a look at our inequalities. You encounter inequalities all the time in real life. No one under 18 permitted. $20 bill. That's an interesting concept. No trucks over $10,000. $10,000, 10,000 pounds. Legal voting age. Pool capacity. Minimum speed limit. Maximum speed limits. All of those are inequalities. You might wonder how a $20 bill is, but that is worth, you can buy anything up to $20. You cannot buy anything more than $20 with a $20 bill. So let's take a look at some of our symbols. As you recall from, you've done this, I think even in elementary school, you've been doing this for a while. This sign is our is greater than. The word is important. If you don't use the is, then it is going to look like adding. Then we have that line underneath it. That line means it is greater than or equal to. And we'll see a number of examples that include equal to. Pointing to the left is less than. Sorry, I'm losing my voice. Is less than. And with the line under it is less than or equal to. Now, I'm not filling in that graph part yet. We're going to investigate that a little bit. Let's think about something. If I said graph x equals 4, we've done this before. We put a little dot on that 4, and that's x equals 4. Now, how do you think you'd graph x does not equal 4? Well, I would put an open circle on the 4, meaning it is not included, but everything to the left and right of it is included. All of those numbers are not 4, but 4 is 4. So all of these numbers over here and over here are not equal to 4. But 4 is, so that would not be included in my graph. Let's see if we can use this information to help us graph our inequalities. So I want x is less than 3. So we want all real numbers smaller than 3. Do I want to include 3? No. So I'm putting an open circle at the 3 because I don't want to include 3. 3 is not less than 3. But all of my numbers to the left are. And you'll notice the end of my arrow looks like my inequality sign. That kind of helps you graph things. Let's look at my next example. X is less than or equal to 3. Well, in this case, it does include the 3. 3 is equal to 3, and all the numbers to the left are less than. So this graph is all numbers less than or equal to 3. Okay, let's take a look at a couple more. X is greater than negative 5. Well, that's going to be all these numbers over here. So it does not include 5 because 5 is not big. Negative 5 is not bigger than negative 5. But all of these numbers are, including even negative 4.9. So all of these numbers are bigger than 5. X is greater than or equal to negative 5. In this case, I want to include that negative 5. And it's all numbers to the right of it. All numbers greater than or larger than negative 5. Let's see if we can look at these and compare them. If x is less than 3, x is less than and equal to 3. X is greater than negative 5, x is greater than or equal to negative 5. Notice when we don't have the or equal to sign, we have an open circle. When it does include it, we have the closed circle. You'll also notice that the point of my inequality goes the same direction as my arrow. In this case, my arrow is pointing this way, my point's going this way, my arrow is pointed this way. So let's look at our graph. Is greater than, open circle, pointing to the right. This arrowhead matches this arrowhead. Is greater than or equal to, closed circle, pointed to the right. Pointed to the right. Is less than, open circle, pointed to the left. You remember from 6th grade, we always said left less. Less than or equal to, closed circle, pointing to the left. I want to talk a little about equivalent inequalities. These mean inequalities that mean the same thing. We know that 3 is less than 5, correct? And 5 is greater than 3. These are the same thing. They mean the same thing. Therefore, if you see 4 is greater than or equal to b, that is the same thing as b is less than or equal to 4. And you want to get in the habit of writing inequalities with your variable on the left. It just makes graphing so much easier. So for this, I would put a dot on my 4, and it would be all numbers to the right of it. Was that a great left of it, because it's less than. Okay, let's write an inequality for some of these situations. I have all real numbers x that are less than or equal to 5. Well, all real numbers x, that's x. Are less than, that's the same as is less than. So that's going to be an inequality, but it's is are less than or equal to. So that's what that looks like. And then 5. So all real numbers x that are less than or equal to 5. Let's look at our next example. 4 less than a number. Now this isn't an inequality. This is subtraction because there's no is. If it's a 4 is less than, but then it would be an inequality. But 4 less than a number means I'm subtracting, and it's a turnaround word. So 4 less than number y is y minus 4. Is greater than, that's that symbol, no or equal to, just greater than 10. Now let's go the other way. We're going to look at a graph and see if we can write an inequality. Notice our circle is closed at the -2, and our arrow is pointing to the left. So we're going to say x, because we always want to write our variable first, is less than or equal to, because going to the left, but it is a closed circle, -2. So all real numbers less than or equal to -2. My next one, I have an open circle at 1, and it's pointing to the right. So that's going to be greater than, not or equal to, because there's no closed circle. And it's 1. How would you write an inequality for this situation? To write this ride at a fair, you have to be over 48 inches tall. The word over is an important word, because if you are exactly 48 inches tall, can you ride this ride? Not according to this. You have to be over 48 inches tall. So your height, or x in this case, has to be greater than 48, not or equal to, because 48 is not over 48. What speeds are you technically allowed to ride if the speed limit's 25? Well, we can do any speed up to and including 25 miles an hour legally. Now, I know some of you will say, well, they won't pull you over if you're going 30 or whatever, but technically, you cannot go over 25. So, important things to remember when graphing inequalities. First of all, the variable needs to be on the left. Is it wrong on the right? No, but you'll probably graph it wrong if it's not. Write your variable on your left. Don't write it that way, write it that way. By the way, when you notice this, wide mouth is facing the x, so when you rewrite it, the wide mouth still needs to be facing the x. The inequality area points the direction you shade, but only if the variable's on the left. So for this one, my arrow would go to the right. And an open circle is for less than or greater than, and a closed circle is for less than or equal to, and greater than or equal to. That's it. Have a great day.